Welcome to CS3308 Information Retrieval. This is the Unit 5 lecture part 3, and during this lecture we're going to finish the conversation that we've started by looking at safe ranking and talk a little bit about unsafe ranking. Now, if you recall, safe ranking was all about trying to retrieve some number of documents from our index that were the most relevant documents, meaning those documents whose cosine similarity measure was closest to that of the query term, meaning that it was most relevant to the query term, or the documents that most closely matched it. And so SAFE was all about saying, I'm going to guarantee that I get the top 100 documents based upon the approach that I'm taking to do this, which is I'm measuring the cosine and I'm calculating it, and I'm going to take the top ones that are most closest to it. And that was kind of the whole approach of SAFE. Well, unsafe basically takes a little different approach, and it says, you know what, I want to be close, but I don't have to be perfect. And if it saves me a great deal of time or processing, and it allows me to get the results faster, then it's okay. I don't need to be 100% accurate. I just need to be maybe 90% accurate or 95% accurate, whatever the case happens to be. So unsafe basically says, I'm going to let some stuff slip through, but in general, what I'm going to get back to the user is going to be relevant to what they're looking for. Okay? And that's basically the idea behind unsafe. So, just kind of looking at what is it we're trying to do. We're trying to return some k number of documents whose cosine similarities to the query are very high. So we want to get the ones that tend to be more related to the query terms. And for example, if our query terms were home, mortgage, we would want to have documents returned that are really related to home mortgages, right? And so the question is we know that with the safe mode, we had a bit of a problem because we had a potentially a large number of computations, these cosine similarity computations that I might have to perform. And we know that when you had in the metric that we were seeing there is 250 milliseconds, right? We needed to get a response back in a quarter of a second. Now that means everything that we needed to do, reading the terms out of the dictionary and finding the documents that match the terms and calculating the cosine, we have to do that in 250 milliseconds and start returning the results. Now that's pretty tough, so I've got to be very efficient, and I can't be scanning through hundreds or thousands and thousands, maybe hundreds perhaps, but not thousands and thousands of these documents trying to calculate and make all those calculations. I simply don't have the time or the processing capacity to do so. So we're all about, in unsafe, we're all about trying to prune stuff a little bit more aggressively. And if we happen to prune one that was good and may have been really relevant, well, that's okay, because the majority of what we're going to return is going to be relevant, right? So I might get it wrong sometimes, but I might get mostly right, and that might not be so bad. And that's really kind of the basic idea behind unsafe. Now, we have to think about cosine similarity. This whole process is basically only a process. So what we're focused on doing here is that the user has a query. He's going to put a query out there. We want to try to match those query terms using cosine similarity as much as possible. And the basic concept is, you know what, if I'm close, it might be okay. It might still keep our users happy. So that's really kind of what we're focused on here with an unsafe model. And to do that, to accomplish that, I have to start trying to figure out how to do things such as eliminating stuff off from the index, right? So, for example, one of the concepts we have is that, I'm only going to return a document if at least one of the query terms is matched. By the way, what I did is I eliminated the vast majority of what's in the index. I mean, the vast majority of what's in the index doesn't have any matching query terms. So I'm already doing some elimination of the index. What if I could take that further? What if I could say, not only am I just going to look to make sure that the query term matches, but I'm only going to take one of those query terms if it happens to have a really high IDF value. right? Another thing I might want to say is, let's say that I have 4 different terms that were placed in into the query. So it's home, mortgage, rate, interest. And this is really stuff related to somebody looking to buy a home and is interested in what the current interest rates are for purchasing homes and mortgages. So, the question then becomes, technically, I would return something if it has any of these terms in the index, right? So maybe if a document only had home in it, I would return that document and it might be part of the processing. But, I could get a document that has home that has absolutely nothing to do with mortgage or interest rates or getting a mortgage. So, maybe one of the strategies that I can consider is to only take documents containing multiple query terms. So I'm not just going to say one. Maybe I'm going to say I want to look for, first of all, ones that have all 4. And then if I don't have enough documents, then maybe I'll take 3. And then if I don't have enough documents, I'll take 2. But the starting point is I'm going to say, let's try to keep all 4. So these are a couple of concepts. And the objective of these approaches is that basically you're kind of eliminating a portion of the index. You're reducing how many things that I have to go compute the cosine similarity for. We already mentioned this is to look at the high IDF query terms only. We know that these terms, basically the TF, or the term frequency, or how frequently a document appears in a document, is important when they appear multiple times. We also know that IDF is very important as well. And when I have a low IDF, right, it means that it has very little value simply because it appears on many, many, many documents. We also know that terms that have a high IDF are those that don't appear very frequently across all of the documents, so they're much more relevant to the thing that I'm looking for. So the idea in this particular case is I can just ignore all the terms that have low IDF and really focus on ones that have a high IDF. So for example, maybe catcher and rye, and totally ignore the words in and the, because they just don't contribute much information. So that's another strategy. Don't even look at them. Don't even compute the cosine similarities for them, and it reduces the amount of processing. Again, this concept of looking at many query terms. So, for example, other than the example that we had, if we had 4 different query terms, home, mortgage, interest rate, we could make it a rule to say that I'm not going to take any document that doesn't have at least 3 of them. Maybe I can even start it saying I'm going to only take documents that have 4, and then if I don't have enough documents to fill out the 100 documents that are, or whatever the value of K is, then I can say, okay, maybe I'll take some ones that have 3, or maybe I have ones that 2. But the idea is that I eliminate a large number of documents simply by saying I'm only going to take the ones that have the majority of the terms, of the query terms that are in there. And this works particularly well when I have, queries where people put in multiple terms, 3 or 4 different terms in their queries. I want to talk a little bit about the concept of champion lists, and I know that your book's going to talk a little bit about them. And the basic idea behind a champion list is this. If I take a group of high IDF terms, okay, I can pre-compute weights for just the ones with a high IDF. Maybe I pre-compute some of the similarities just for the high IDFs and put them in a different list. So I'm not even having to look through the ones that have low IDF. I'm just going to go to my special list. The special lists are the ones that just has the high IDF ones. That way I don't even have to scan through them, and I just pull off from the top of the champion list. And that's basically what a champion list is. It basically says I'm going to take all of the documents that have a high IDF value, and I'm going to stick them in a special list, and those are the ones I'm going to go get from. All the other ones I really don't care about. High and low lists, similar concepts. I can kind of put a high maybe a champion list, and a low is things that are not in the champion list. And the basic idea behind the high and the low is assume that I went through and I took all the documents out of the high, and I still didn't have enough to fill the need. So again, I still have some value of K, and maybe K is equal to 100. So maybe I went to the high list. The high list had 35 documents in it. Well, I still need a few to fill out the K equal to 100, and that's the point I would perhaps go and start selecting some stuff out of the low list. But again, all of these approaches, as you can see, since I'm focusing on trying to keep the most relevant documents out first, and I'm trying to kind of limit what I'm calculating my cosine similarity on in terms of just the most relevant documents, again, under the assumption those that have the highest idea value will tend to be the ones that are going to be more relevant. And so the idea is that I'm putting all these techniques in place to make better bets, if you would, on what documents to pick, and the potential that those documents will actually be the ones that are more relevant. Again, I'm not guaranteeing it. This is an unsafe approach. But these techniques do tend to kind of put us into a position where we have a relatively high likelihood that we're going to get the most relevant ones. Another thing that we can look at, and I believe this is the final concept we're going to look at real briefly in this discussion, is the idea of tiering the indexes. So we can kind of take our indexes and break them into multiple indexes. So not even just having a set of lists, but maybe I have an entirely separate set of indexes. I kind of have the high-end index, which is the most important, and maybe a low-end index are the ones that are least important. And again, organizing which index you place them into based upon their importance as measured by the weight. And we have just kind of a real quick illustration of that. So for example, maybe we have some stuff that are in tier 1 because this set of documents have very, very high IDF values in terms of weighting on these terms. Not so high in tier 2, and then relatively low in tier 3. Again, the idea is that by doing this, I'm just taking the ones that are most likely to be highly relevant, and I'm going to look at it first. And I'm only going to go into this tier 2 or this tier 3 index if I need to find some additional documents, if I didn't get enough documents by looking at the tier 1. So hopefully that gave you a little bit of an overview and a sense of the concepts of Unsafe. I'm going to really look for you to go through the readings for this week, because it's really going to fill in all the details around some of these techniques.